All right, what we're going to work on today is the half angle formulas. All right, we did the double angle formulas yesterday, so today we're going to work on the half angle formulas. And with the half angle ones, we're only going to do sine and cosine. I'm not going to do tangent. So just sine and cosine. Now, if you look at your formula sheet and find the half angle formulas, I don't like the way they're written on the sheet. So I'm going to show you how I write them. And you may want to write this on your formula sheet as well. It really doesn't matter, but I guess it's just the way I learned it. So that's the way I know it. So let's see. How do I write them? This is how I write them. Because if it says half angle formula, shouldn't it be half an angle? And that's what half an angle looks like, theta over 2. Now your formula sheet has this is theta and this is 2 theta over here. It doesn't matter. It's the same thing as long as this angle right here is half as much as this angle right here. All right. Now, where do these formulas come from? They come from the double angle formulas. You hear a kid screaming out in the hallway. That's one of my grandkids. I think that's Catherine. She may open the door and yell in here, but maybe that won't happen. All right, so you can tell these formulas also look almost the same. The only thing that's different is that sine has a negative right there and cosine has a positive. Do you have to memorize those? No, you use your formula sheet. Now, I had to memorize them once. And the way I remembered it is that sine had the negative. Sin is like the opposite of what you're supposed to do. That made sense to me. Sin is the opposite of what you're supposed to. It never stopped me. I always end up doing it anyway. But yeah, so let's see. So sine's got a negative, cosine's got a positive. All right, these are what the two formulas look like. Now, let me give you an example of what it looks like when you plug numbers in. All right, so let's plug in something for, all right, let's say, all right, so let's say sine of 75 would be equal to plus or minus. Now, plus or minus depends on what quadrant you're in. So this is quadrant 1, it would be positive. All right, what would go right here? All right, what would go right there? All right, what would go right there? So this angle right here would have to be half as much as the angle that goes right here. So if 75 is half of that angle, what would that angle have to be? It would be 150. All right. So when you set up a half angle formula, this angle needs to be half as much as this angle. All right. That's the relationship between the two. So if I saw cosine of 15, all right, cosine of 15, this would have a plus in it. All right. What would go right here? All right. What would go right there? So this angle has to be half as much as this one. So that would be a 30. All right. Now, I'm not evaluating this. I'm just showing you what the relationship is when you plug stuff in. This is what it looks like. I'm not evaluating that. Well, let's do an example of where you would evaluate something like that. All right, let's suppose I wanted to find, let's find cosine of 15. Let's do that. All right. The directions are find cosine of 15 degrees. Well, if you're going to use a half angle formula, do you know something about twice that angle? All right. Do I know something about twice that angle? Well, twice that angle, twice 15 is 30. Do we know something about 30 degrees? Yes, we do. All right. So to use the half angle identity, we're going to say cosine of 15 is equal to, all right, so it's going to be 1 plus, all right, what you're going to put here is twice as much as that angle. So we're going to double 15, we're going to get 30. All right. Can we evaluate this side? Do you know what cosine of 30 is? Yes, you do. Look on your unit circle, look up 30 degrees, and what is cosine of 30 degrees? Cosine of 30 degrees is root 3 over 2. All right. Now, this is a mess. I don't like that. You don't either. All right. What I really wish that 2 right there wasn't there. Well, can you get rid of it? Yes, you can if you multiply the top and the bottom by the same thing. You got to multiply them by the same thing. So what would get rid of a 2? A 2. If you multiply the top by 2, you got to multiply the bottom by 2. Whatever you multiply the top, you got to multiply the bottom. All right, so let's see. We're going to distribute the 2. We have to distribute the 2. Yeah, I told you this is a mess. All right. You didn't believe me, did you? All right, so let's multiply everything by 2. So 1 times 2, that's 2. Root 3 over 2 times 2. The 2's cancel on that one, so it's just root 3. On the bottom, 2 times 2 is 4. Okay. You can't take the square of the top. Just leave it. Just leave it. But you can take the square of the bottom. You know what the square root of 4 is. The square root of 4 is 2. Now, is that not one of the ugliest numbers you've ever seen? The square root of 2 plus the square root of 3 all over 2. Ugh, that's an ugly number. But that's what cosine of 15 degrees is, and that's the exact value. Now, I know you could type that in on the calculator, but what you see is not the exact value. This is the exact value. All right, let's do another one. Let's throw a pi in there. Okay, let's throw a pi in there. All right, so let's see. Let's find sine of pi over 8. Sine of pi over 8. Okay, now the key is, do you know something about twice that angle? What is twice pi over 8? Do we know something about that? What's twice pi over 8? Well, that means pi over 8 times 2. How do you multiply pi over 8 times 2? Well, you cross-reduce the 2 and the 8, and that's pi over 4. All right, so that's the same thing as pi over 4. Do you know something about pi over 4? Do we know something about pi over 4? Yes, we do. We are very, very familiar with pi over 4. So we're going to use the half angle formula for sine. So I'm going to write sine of pi over 8 equals, now the formula for sine is, here it is right here. Remember, sin is the opposite of what you're supposed to do, all right? But I do it anyway. I did all kinds of crazy stuff when I was a kid, all right? I won't say it in the video because that's permanent evidence, so I won't do that. All right, so let's see. It's the square root of 1 minus cosine. Now, what do you put right here? You put twice that angle. What's twice pi over 8? Twice pi over 8 is pi over 4. So that's the formula, but on this side I got pi over 8. Right here I have twice that, which is pi over 4. All right, we can evaluate that. We know what cosine of pi over 4 is. It is the square root of 2 over 2. Now, you saw how we simplified the last one, so you can probably simplify this one. What you're going to do, I don't like that 2. I know you don't either. We're going to multiply the top and the bottom by 2. All right, that is going to give me, what's that going to give me on the top? You have to distribute the 2. 2 times 1 is 2. This, what happens on this right here? What happens to the 2's right here? On here, the 2's cancel. You just get root 2. The bottom, 2 times 2 is 4. Now, you cannot take the square of the top. This one's ugly just like the last one. You can't take the square of the top, so just leave it. And then what's the square of the bottom? The square of the bottom is just 2. Again, a very ugly number. But numbers can be ugly. We can like them too. Doesn't matter if they're pretty or not. All right, so that's the answer. That's sine of pi over 8. That is the exact value. All right. So we're going to come back in the next video and do a couple of different examples of how to use those formulas, but you'll see it and it shouldn't be too terribly bad.